I am your organizer for Azure Data Engineer training. Okay, it takes nearly 2+ months of training. If you have any subject-related doubts, our faculty Shekhar sir explain all the things about our course. If you have any subject-related doubts, please ask Shekhar sir. If you have any experience-related doubts, please contact me. I shared my contact number to you. Okay, in WhatsApp. Thank you. Thank you for attending all. Please continue, sir. Thank you.
Yeah, hope my screen is visible. Hello. Can one of you please confirm whether my screen is visible or not? Yes,
Yes,
it's
sir.
started sharing. Yeah, thank you so much. So today's agenda is data engineering demo. So as part of this demo, we learn fundamental points. What is data engineering? Yeah. Followed by what are different technologies? What are different technologies we are having? On data engineering. Then followed by, after this, why cloud-based data engineering technologies are getting popular nowadays. So these are the predominant points, and prior to this, we should understand a term called big data. So traditional systems, this is another point. Next concept would be here big data, traditional systems followed by big data one. Big data technologies, or else distributed computing. This is what we have to understand. In order to understand the fundamentals related to the data engineering, followed by big data engineering technology stack. So these are three components. First, we have to understand in the order, then we can get to know about. Yeah. So what is a data engineering, or what is a data engineering concept talks about, and why this is being popular, and different data engineering technologies we are having, supporting, current data engineering needs, followed by cloud-based ones. So very detailed insights we are going to see. And once we are done with this, we will again have a diagrammatic representation in understanding these traditional systems and the distributed systems. So I give a comparison as well. So first, let us quickly get into these traditional systems. What are these traditional systems and all? We have to understand existing traditional systems. First one, file-based systems, long ago, 3 decades, followed by RDBMS engines we have got. Next one, data warehousing engines or warehousing engines we have got. So these are traditional, systems or technologies we are having even at present market, and what are the drawbacks of it, and what are, distributed computing technologies to solve the drawbacks and how. So this is what here. And these are the systems, the traditional systems are being used for representing the data. So nowadays data is widely popular. These systems are, of course, being meant for storing the data, storing as well as processing as well, storing and processing as well. But what is the problem of these traditional systems? If we take RDBMS engines like data warehousing engines, file system, very old one. So here drawbacks are data redundancy. So duplication of data, that is data is repeated widely and there is no guarantee for the uniqueness. So that is why here, this is first one, and RDBMS engines have come, overcoming the drawbacks of these traditional file-based, or file systems drawbacks that RDBMS engines have come. And what is the data model being supported? So we have to enforce normal forms, normal forms to our data before we store data into them, before we store data into these systems. So that is what, by applying normal forms, what we do. So we bring structuredness. That's why these are structured stores, structured data stores. So this is primary rule we have to follow before we store data, and the same almost even to these data warehousing engines as well. Yeah. So, but here we can maintain history of data as well. We can maintain history in these systems. This is another flexibility, and these systems drawback. Of course, we predominant flaw of these engines is we have to bring structuredness to the data, and here these are being meant for storing and processing. Of course, using both of them, we can process the data as well. But why we have got, I mean, predominant drawbacks if we highlight. So nowadays, data is becoming wide and wide. Yeah, data. Let us say here, data and data sources we are having multiple data sources. So data is being generated not only by our applications. Applications are not only being generated, only being generating data. So what does it mean? Applications means here, for example, if we take any e-commerce websites are best examples. Yeah, for this one, we place an order. So order details, transaction details, customer details should be stored. So such kind of data is nothing but your, application data, and we bring structuredness by applying, or by implementing normal forms to this data. So that is what here one of the data source, that is application data. And nowadays we have got, mobile data as well, mobiles data, followed by mobiles from mobiles as well, and IoT sensors based data. Mostly this is in JSON format data, and mobile social media. Yeah, best example, social media we can say. For example, WhatsApp conversation. This is comes under unstructured data. Unstructured data conversation. We can't, that is, we cannot bring structuredness to this data. Whereas IoT sensors data generate in the form of key value pairs and JSON formats starts with this notation curly braces and then followed by key and its respective value, followed by multiple key value pairs we would have in this format. So these are various sources for nowadays data, and predominantly social media data is getting highlighted and widely popular. So data volume is getting huge. So that is also one of the one of the drawback of these traditional systems. Though we apply, you know, we can apply structuredness rule on this data. Yeah. To this data, but not for these. So, but how can we store these systems data as well? Because these traditional systems, as we discussed, both RDBMS engines and data warehousing engines are not in a position to handle these with kind of data that is for storage purposes, as well as we cannot bring structuredness to these kinds of data, and hence we are not able to query this data. Once data has been stored, storing is not a big problem. We have to do some analytics on top of it, or we have to perform data insights for our business. To do so, we have to depend on alternate technologies apart from these traditional systems as well. For example, in these traditional systems as well, we are having, let us say, data. And when data volume is getting increasing, for example, let us say 500 GB of data we are having, only the structured data I'm talking about. Forgot about the remaining types of data here, unstructured, and this one as well. This comes under semi-structured data. Yeah, semi-structured data. Forget about these. Yeah, only application data. So as of now, we have got this one, and next 150 GB data has been increased for our application. And if this data is keep on, increasing, so what we supposed to do, we have to add certain components needed to store this data. And at the same time, when we try to perform analytics on top of this data or would like to do data insights, in such a case, we have to do data processing as well. This one would be data storage. Yeah, that is first one. Second one would be data processing. So what is the language we are having here? Using SQL language, we used to process the data. We used to do analytics on top of this one. For example, sales details. Sale details of a KFC store, let us take. Yeah, based on store location. Then in such a case, we usually write grouping SQL queries because we have to perform grouping on this one. That is store underscore location. Yeah, followed by what we would like to do. We have to perform sale amount, sale underscore amount as they sale some alias from sales table, group by store underscore location. So this is usually we write to get the insights, data insights for every store. So to accomplish this one, when data volume is getting increasing, so these traditional systems like RDBMS engines and warehousing engines are not in a position to process this data because of its scalability obstacles. It's their scalability obstacles. So what is that scale? What are those? And in what aspects we are having those scalability, obstacles? First one would be, so we should add when data volume or data size is getting increasing, we should add disks to those systems, to those engine, to these systems or traditional systems. So that is fine. But how we usually add, and then we have to add computation power as well. Computation power as well to perform data insights. So these are systems we are having. So visually, if I say this one, in this way we are having. So these are traditional systems assuming single computer we are having here or a data center having computation. And if we say this one, this is as our RAM. And second one would be another box I need for disks storage. Yeah. So in this way, let us try to fill this one and disks for this one. So here we are having disk and RAM. So for new capacity, if we need, some other, let us say 100 GB volume of data we have got. So like this, we have to, just a second. Yeah. It's over here. We have to add another disk 2, let us say here, and capacity, including CPU as well, not only RAM and CPU also. CPU capacity. So like this, we have to add these stuff to single machine that is part of the data center. The same single machine is getting its enhancements by adding these, increasing its capacity with respect to data storage, followed by the computation power. Yeah, so like this, for example, another copy of another 100 GB we have got. Again, we have to come back to our data center and add to this machine the required capacity. And if anything goes down with respect to this disk crash happen, yeah. So then in such a case, what is that feature? Yeah. If anything fails, if disks fails, yeah. So what is the case? So we have to obviously lose the data that has been stored, and we have to do or wake up immediately on priority basis and restore or replace this disk. So these are obstacles we are having with respect to these traditional, I mean to say traditional systems we are having. That is, when data volume getting increasing, these systems could not be in a position to handle traditional systems. A single machine we are having here. Yeah, machine. So these are the predominant drawbacks of this one. And if anything goes wrong, for example, this gone wrong, then we should not be in a position to handle the data corruptions or any such kind data failures happen, right? Disk failure. So highlighted in red color. So then in such a case, we in just a second, increasing the font as well. Yeah. So this one failed. If this get failed, it becomes obstacle. So then in such a case, how can we handle these failovers? We used to technically call them as. So these are problems of big data. What are those? Data storage problem if data volume is keep on increasing, and data processing problem as well. And coming to this one, these obstacles. So by keeping all these obstacles of these traditional systems, and moreover, so data type, these cannot be data variety or data types, let us say, for a simple understanding sake, structured data. Yeah. Then we are having semi-structured data like JSON and Excel, best example. Oh, sorry, XML. Next one would be unstructured data. So best examples here are your text files like PDF file, Word document. If you want to perform analytics on top of it, how many times a word has been occurred? Yeah, Word document like this. So these are text files, and unstructured data again, audio files, audio and video files. Next one would be images. Nowadays we have got these face recognition stuff. So how our face get recognized, and thumb impressions as well, biometric. So coming to these are JSON data. And then XML is best example for these kinds of data, and we could not be able to be represent. And structured data, obviously, RDBMS engines data. RDBMS application data. So these are best examples, and we could not represent using these RDBMS engines, I mean to say, as well as data warehousing traditional engines, and we cannot be able to perform analytics using these traditional systems. So that's why we have got these, you know, distributed computing engines to perform these. So what are these? To address the drawbacks of these traditional systems. Addresses the flaws of these traditional systems. What is this distributed computing or distributed computing existing technologies we are having? So here, simple and straight, instead of single machine usage, we use multiple machines. But how? Yeah, so this technique here, whatever computation needed, we are keep on adding in this, yeah, to this a single machine. So this is what here scaling technique. So we are enhancing our single machine. That is nothing but we are scaling. So that's why here these terminologies are important and these terms has come. So we are scaling this a single machine. We use multiple machines connected via network. Connected via network. How these systems looks like. Let us draw a diagram. This is our machine one, let us say. Yeah, same properties, same stuff needed here. So just give me a second. Yeah, I'm keeping in this way instead of, because they are not, this box is not going forward. In this way. And the same here, the same features for another machine. So this is your machine 2 and your machine 3 here. And these machines are connected, well connected with, network. Machines all are connected well over network. Network agent. This is the diagram. Yeah. So this is how, for example, and these computers talk each other. Yeah. So these computers talk each other because they are well connected with internet. I mean, a network or, yeah. So this is how they connect together. And for example, due to any reasons, if disk 2, for example, this machine 3, disk get failed, then in such a case, we should not lose the data that gets stored on this one, and our application should not face any issue. So this is what also, that is failover problem also being addressed using these distributed computing. And for example, we have got, as we discussed, 50 GB volume of, sorry, 1 terabyte volume of data we are having, and these systems are being handling it. But how they handle and all, that is completely proprietary to the distributed computing, distributed computing. Just this one. How these systems, how these systems handle data that got stored in them is fully or is proprietary. Is proprietary. So they won't reveal in fact, and it moreover it differs from distributed computing technology to technology. Yeah, this is what here we are having. It differs from technology to technology. So we do have multiple distributed computing technologies, and one among I reveal that one as well. So this is how, you know, we addressed data or any issues, failure issues we are having, if any, then those are addressed here. And next we have got another, let us say 25 GB of data we have got. Then in such a case, what we do is, for fulfilling the requirements of newly arriving data and for processing of the data computation needed, we add another computer to this, or simply to this network, simply to this network. Again, these are get connected over network each other. This computer also get connected to it. And here also, just one is enough, but for visibility sake, I have drawn this one. So like this, we keep on adding machines based on need. And as I said, one of the term, this is called vertical scaling. Scaling aspect, vertical scaling, this technique, single machine enhancement. And here, scaling aspect of technology stack, technologies. First one, traditional computing, horizontal scaling. Best examples are traditional technologies, whatever we are having, RDBMS engines and all. And here, what, sorry, vertical scaling. This is first one would be vertical scaling. I'm sorry. Vertical scaling. Adding power needed to this, to a, or to the same computer, to the same computer or machine, we can say. That is vertical scaling. And these distributed computing technologies follows horizontal scaling. Scale out. This is also another name is also there. So here we simply add machines, based on need. So this is what here the architecture implementation or the strategy being followed. And these are, horizontal scaling or distributed computing technologies address the issue of, failovers that could be related to data disks as well and computation also. Multiple advantages we are having. And once we deep dive into these distributed computing technologies, we can understand, yeah, because this strategy and being implemented differs from, as I said, technology to technology. And popular big data or sorry, distributed computing technologies or big data technologies. So what is big data and what are those big data technologies, Hadoop, and what is the relation between them, between these two, Hadoop and, big data. So the big data gives guidelines for distributed computing, and whereas Hadoop implements this one. Hadoop, a software framework implementing guidelines. Yeah, big data or distributed computing. Easily fine. Yeah. So this is what here, one of the most popular one, and Hadoop and its ecosystem we are having as part of it big ecosystem. So and again we are having multiple again platform providers. Similarly, how we had just a second, please. Yeah, platform providers, Cloudera. Hope you some of you might heard about them. Hortonworks are acquired by Cloudera as well, and MapR. So I worked on MapR platform, right? So like this, we are having platform providers for this technology, and this is what here big data technology and distributed computing being implemented. So this is what we are having. And coming to, yeah, so this is also related to big data, where we are having big data technologies association, data engineering. So from big data technologies, Hadoop onwards, this term data engineering or data engineer has been popular. Yeah. So implementing these big data technologies on cloud is nothing but data engineering on cloud. Simply big data implementation on various clouds we are having. So for storing these kinds of data we are having, and let us deep dive into certain aspect of big data technologies, because we are having traditional systems drawbacks, because they only address or be able to store structured data. So how about these data types we are having? Unstructured data followed by semi-structured data. So who is going to address these? Yeah, RDBMS one. So here, big data technologies addresses these technologies. I mean, these kinds of data. So what are features of big data and all? Let us quickly understand. Address traditional systems. Issue. So what is predominant issue? So data type. So before this one, yeah, data type is one of the feature. We have to understand the features being supported by these big data technologies. And first one would be here, obviously, volume of data. Volume. When data size is getting increasing from this diagram, yeah, our systems are failing with respect to what? With respect to performance aspect. Data storage problem we are also having, because we have to depend on, adding storage when needed and computation when needed. So these are predominant problems and couple of predominant problems of these traditional systems. And again, Yeah, data processing wise, if we take this one as, here, data storage. Yeah. So these three kinds of data it is able to store. That is called variety of data. Variety of data feature that is being supported by big data. Let me disconnect this one. This is the second feature we are having. It supports both these three flavors of data classification we are having. Then structured data. Yeah. So this one we are having. And volume of data. Obviously, volume feature represents or talks about size of data size and massively scalable till petabytes volume of data. Yeah. Volume, velocity. Velocity talks about speed of data. Speed, data, speed. How speedily our application is getting data. So again, here we are having a couple of aspects. First one would be here. This velocity feature also having dependency of volume as well, on the volume as well. Why? Because is having dependency on it. Okay. So here, velocity, right? Small volume of data, small volume of data. For example, MB volume of data we are receiving, and we are having huge volume of data in terabytes or zettabytes volume of data. So how this application small volume of data should be processed? Should be processed. It depends on multiple aspects. The frequency our application is getting this, small volume of data, and based on business need, we have to process it. So this is what here predominantly talks about the feature velocity. Again, data processing aspect, if we deep dive into these big data technologies, we are having a couple of types. First one would be, batch processing. This is what here we are having batch processing and real-time processing. So this real-time processing is having dependency on the velocity feature as well, because we are receiving every time, you know, let us say 100 MB volume of data we are receiving, and we have to process it once it has arrived to our application. So this is called real-time processing. So we are having multiple frameworks for processing. I am not going to deep dive, but this is feature. And velocity is having dependency on the volume of data as well. If we are receiving huge volume of data, GB volume of data, it is not advised to take leverage of real-time data processing feature supported by these big data technologies. Yeah, so this is always volume of the data, that is size of data our application is holding, and variety of data. And big data technologies are giving solution for these varieties of data we are having, unlike traditional systems like RDBMS engines and data warehousing engines. Yeah. So here, second feature would be data processing. So these are predominant couple of problems we are having with respect to traditional systems. Why I'm emphasizing on this is again and again, big data technologies or distributed computing predominantly popular because of these drawbacks and widely used when the social media has coming to our life predominantly. Yeah, so here we are having both batch processing technologies here, and second one would be, you know, real-time processing technologies we are having for this one. So based on our application need and how our application is accepting or getting data, we have to choose the right technology. Yeah. So in this segment, I mean to say big traditional, big not a traditional, this one big data technologies. We are having, data storage. Again, this data storage is being classified. Yeah. So that is again a deep dive step we are doing at present. So based on this type of data being classified, the storage, the storage is also being classified. Yeah, I mean to say storage engines being supported by these distributed computing technologies, that is nothing but here big data. Yeah, yeah, so have been classified. Again, if you are having these structured data, then we are having data storage, big data technologies are offering data storage engines or let me write here. I don't want to deep dive into big data, sorry, cloud on right now. So here RDBMS engines, then data warehousing. This is first flavor. So anyway, yeah. So these are flavors and it is not right time. Yeah. So I again come back to this one, data storage classifications. So that eases our understanding of, you know, various technologies we are having in big data world, because I would like to deep dive into that, because I would like to draw a big node like this main node I would like explain. Right. So these big data technologies are also, popular, but they incur cost because we have to set up data center and we have to maintain it. So this is bigger obstacle we are having with respect to these big data technologies. We are having predominantly. So we have to take care of both setup and maintenance aspects, costs incurred for that. So obviously business has to invest money to set up data centers, right? So instead, why can't we use the same money for our business enhancements and take leverage of, you know, these big data technologies being offered on various cloud providers? So that is the thing, and they had in mind, you know, I mean, nowadays scenario I'm saying. So present business is thinking in these aspects instead of taking this burden. So they would like to prefer go for cloud technologies, and that's why cloud technologies are being emerging with respect to data engineering and data analytics. Let us say a data analyst role as well, and data science roles as well. So predominantly we are having these three roles, data roles in our IT. So data analyst role, predominantly this guy need, you know, Python programming language. Python is mandatory and SQL. Apart, he need Excel, good player with Excel for performing dashboards as well. Self reporting, self service, I can say. Next one would be reporting tool. Reporting tool, Tableau or Power BI. And coming to data engineering role, obviously these two needed. These are prerequisites, guys. If none of you, any one of you are not having any, learn them. Any one is missed, you have to enhance your skill. Apart, What else we need for data engineering? Data engineering on on-premises. Then big data is popular. Yeah. So, and its ecosystem. Hadoop. Let me write it down here in stuff. Hadoop and its ecosystem. Most of you heard. Yeah. Data engineering on cloud. Major cloud providers we are having AWS. Second one would be Azure and GCP, Cloudflare. And even SAP is also had offering cloud-based. Multiple we are having, but these are widely used ones in the industry. And data science role. Here, obviously, yeah, data science role or data scientist role either is fine. So better you should have data engineering knowledge. This is added advantage. And if you are a data engineer, you can easily upskill and become a data scientist. And it is having multiple wings, in fact. Machine learning, first one, and AI technologies involved, and followed by data science specific related stuff. These three things together, uh, you know, data science, including this one, of course. Data engineering is also part of data science and data analyst or analyst role as well, or analytics. Data science is a big wing. We used to address this term, you know, big data landscape. Big data landscape. As part of this, we are having all these three roles: analyst, engineer, and data science roles. But we are working with these big data technology landscape on nowadays clouds instead of this one. Drawbacks, whatever we are having to overcome them. Yeah. So this is brief overview of this one. And coming to, data engineering, I mean to say with respect to both big data technologies as well as the cloud one. So traditional we are having. All right, minimize this. Okay. Data roles. Fine. Yeah. So whether it is again data storage engines classification. First one. Relational or databases or DBMS engines. Yeah. Next one, data warehouses, data lakes, data lake houses. In fact, it is a single term, lake house, followed by NoSQL databases we are having. Yeah. So fifth one this is. And again, this NoSQL has been classified into inner segments. Come on. So something wrong. It's freezed. Xmind is freezed. Wonderingly. Not allowing me to select any. Hello, Venkat. Can you please pause the recording to cloud?
Hi, Al. Please ask your doubts.
Hey, hi Venkat, this is Mohan speaking. So,
Yeah.
may I know, do we receive the recording once the session is completed, as I joined
Yes,
late?
yes. Yeah, yeah, no problem. You can take it.
Okay.
But those recordings are not downloadable. Okay, I will share through privately.
Okay.
You have 1 year of access for that videos.
All right. So we got it. NoSQL databases, and it is again based on different classifications we are having in this NoSQL segment. First one would be key value pair databases. Second one would be document oriented databases. Document oriented databases. Third one would be columnar. Columnar, or another name would be column family databases. And finally, graph databases we have. And all these predominantly classified based on the need and the data model being represented. So, and these four kinds of NoSQL engines or databases follow a theorem called CAP theorem, and it stands for consistency, atomicity, and final one, partition tolerance. First couple of features, consistency, atomicity, or most of us heard in traditional databases as well, but partition tolerance. What is this partition tolerance and all? Again, it is out of scope for because this is a distributed environment, right? We are playing with these big data technologies and all. That's why here, how the data is stored or being represented, how to process the data once data has been given to these distributed computing or distributed computing engines that could be for storage as well as processing. We have to deep dive into it. If you are having big data background, then you are well aware of it, how the data is going to be stored on these distributed computing engines, or anyway, with respect to both data storage and processing. So the same here we have been, or we will implement on cloud platforms, except that nothing great. And here we are having on, I mean to say these are specific to NoSQL databases right here. Yeah, so big data technologies, data warehouses. Yeah, cloud providers. Next one, Azure cloud. If we get into this Azure cloud, and here all these, just a second, all these things, control enter. Yeah. Data storage classification. Yeah. So this data storage classification has given us this much depth subject. So this is what here we are having data classification as this. And once you get into this, I mean to say here, if you are in big data technology stack, it is not proprietary. Another highlight point here is on big data technologies, these technologies, I mean to say, big data platform providers. Who are they? Cloudera, then Hortonworks, MapR. If you go to these, any of these platform providers, that is, they give us the platform to develop our applications and all, the technology stack remains the same. Yeah. This is added advantage when we are dealing or working with big data technology stack. But coming to cloud providers, yeah, it has been changed to cloud proprietary solutions, cloud platform providers for big data. For example, if you take AWS, Azure, and then GCP. The same data storage classification is applicable with respect to these cloud providers, AWS, as well as Azure, as well as GCP. Yeah, so as I said, a statement that these become cloud proprietary. All these storage classifications as well as data processing also became cloud proprietary. So on AWS platform, we are having RDS, stands for Relational Data Stores, and Redshift we are having, and data lakes we are having S3, stands for Simple Storage Service. Yeah, data lake and lake houses. We are having the same data lake house, sorry, S3 act as both lake and lake house based on the computation engine we use. Forget about that for time being. Key value pair here we are having, and document oriented databases, separate a separate proprietary service we are having. I don't know these, I forgot these names, service names being offered by AWS under this classification. Here for graph oriented databases, we are having DynamoDB. Yeah, here this is DynamoDB. This is document oriented NoSQL flavor under AWS platform. Graph oriented, I am not sure. The name starts with N. So like this, once we get into Azure cloud, we are having here RDBMS engine as Azure SQL database. Nothing but SQL database, nothing but SQL Server on cloud. That's all. On-premises SQL Server on cloud has been renamed to Azure SQL databases. So here we are having Synapse Analytics. And data lake here we are having The name is Azure Data Lake Storage. And again, we are having generation 1 and generation 2, and popular one and widely used is Gen 2, generation 2 one. And the data lake houses we are having. It is nothing but one lake we are having and widely used in Microsoft Fabric environment. Microsoft Fabric environment. And if you use Databricks, then it would become your data lake becomes data lake becomes lake house if you use this one. And coming to NoSQL, all these flavors, four we are having, right? Yeah. So single database called Cosmos DB. Cosmos DB. Microsoft Azure is the only cloud provider who is offering a single database of type NoSQL database, providing support for various NoSQL databases flavor had in the market. Yeah, so keep this in mind. It is a multi-model and globally distributed. Forget about this one. For time being, it is confusing you. Multi-modal NoSQL database on Azure Cloud offers various models being supported by NoSQL databases. Yeah, so this is what here we are having with respect to this one. And coming to GCP, we are having Cloud SQL. If you want to avail RDB Mesh Engine, you can avail. And here, BigQuery. Name itself is BigQuery. And Big Lake. Data Lake only, right? I'm sorry. It is Data Lake. Google Cloud Storage. We are having here. And coming to Big Lake. We want to take leverage of Lakehouse features. Why this is needed? A big story we have to discuss later. It is out of scope. And coming to NoSQL, we are having again multiple databases in this GCP platform as well. NoSQL, we are having big table of type columnar. That's we are having. I haven't remembered these names. Yeah, but widely used one is big table. Yeah. So these are the technology stacks we are having. And so coming to data engineering, that concept is pending. I cover that as part of next session, guys. So what are data engineers roles, how your daily work looks like, how we do get work? So that is being discussed as part of next session. So before we discuss any other questions, let me know, please. I'm trying to remember. I think this is file store on Google Cloud. Yeah, this one, file store. Key value paid for purposes. Any questions? Let me know, please. Hope it is clear. Yeah, I'm dropping. Yeah, Venkat, I'm done for today. Demo. Any questions from your end?
Hello.